So I will present the other use case related to UAVs in this project, which is related to long-range inspection, in order to make, let's say, more efficient inspection and road surveys, in order to get as far as you can, and what is required to mount on board the system to make this feasible. This long-range inspection, the main goal is to reduce costs, the operative costs, and also risks related to the personnel involved in this kind of operations. So in terms of cost and time of the mission themselves, in terms of having digitally recorded all the items that could be of interest during this inspection, reducing the susceptibility to human errors in finding this kind of faults by introducing this digital pipeline, and obviously decreasing the risk of inspection operations in terms of the presence of people around the roads or even on the roads. So the plan is to generate valuable and high quality data for the asset owner, and then present all this data in a friendly way to inspect and go back to where each picture, for example, was from where it was taken from, or where to locate the defects in the infrastructure itself. How did we do that from CATEC? Well, we designed a custom aircraft because we found out that the commercial solutions out there didn't comply with everything that we wanted to validate. And we have two main payloads. We have the inspection payload itself. It's located at the bottom of the aircraft in blue, which is a high-end camera, commercial camera, a Sony Alpha 7 model that we integrated in a gyro-stabilized platform to be able to point in virtually any direction. And also we integrated by software program to control the trigger and to store everything properly. And then at the upper part, there's another interesting payload that we call it like the detect and avoid system. It's like a safety payload that also has cameras, but not for the inspection of the road, but for surveying the surroundings of the aircraft to check for potential threats. And potential threats meaning other aircraft that may be flying around and could bring an alarm and to some reason to abort the flight, or to decrease the height, or to stop and then resume the inspection mission, because this is one of the requirements that will be in place in the near future for drone operations beyond visual line of sight, which is the main concept that we are dealing with here. Right now, there are some standard scenarios in the European drone regulations that allow to fly beyond visual line of sight. But for the future integration of these platforms into general airspace with other general aircraft, this capability of the detect and avoid system will be a requirement, and this is something that we found interesting to bring, especially this added value operation, not just for road inspection, but for any linear infrastructure inspection or agriculture from very large surfaces or missions that need to be accomplished by this kind of platforms. So as mentioned before by Jose, we validated this in two locations in Florence, in Setefonti Viaduct that Jose Luis presented before, and also in Puliana Viaduct. I can show here some examples of the pictures that were taken from the actual high resolution camera underneath the aircraft. And by a photogrammetry, commercial photogrammetric solution, we were able to reconstruct in 3D the model, a 3D model of the infrastructure. In this case, the two viaducts. As you can see, the pictures were taken from one side because, according to comply with the current regulations, we decided not to fly over the actual road. That will bring more detail to the inspection, but we will be putting some risk on the road users, and we, in that way, we also could see the environment of the road, not just the asphalt itself. There will be some presentations after this one focusing on the actual high detail of the road. But the goal of the UAV inspections in the project was more focused on the surroundings of the road itself. These are also a couple of examples in the Puliana Viaduct, and also a snapshot of the 3D model at the right-hand side. And as you can see, there were some, in this location, there were some traffic, but we were separated enough in order not to have this safety zone that was defined with the authorities to be able to grant permission for performing these flights. Then regarding the safety payload, as I was mentioning before, it was important to detect potential threats around the aircraft. And this was another development that we did in the OMICRON project, because external observers may have a point of view that could mislead the actual threat that is present. Because in this sample image, you can see that they may be too close, the small drone with the aircraft, but in reality, it's not that much. So we decided to carry on board sensors to be able to assess the actual threat with the onboard processing and onboard decision. We didn't validate this fully in Florence. We did this in Atlas Center, which are experimental flight centers that we are managing in Spain. But the use case was very similar, because what we inspected was the actual runway of the airfield. We coordinated flights with a manned aircraft, and we performed this detect and avoid alarm that was raised by the detection of the aircraft using these onboard cameras. And the consequence was to stop the inspection mission, decrease the altitude of our UAV, wait until there are no more alarms, and then resume the operation. So that was the validation of the concept of operation that we want to implement in this kind of systems. Again, as the photogrammetry and the inspection payload was also fully working, this was an example of the 3D model of one of the flights that we perform in this location. And as you can see, even from the lateral view, the level of detail is really high. It also depends on the actual parameters of the camera that you use, or the focal length, or there are a number of variables that you can play with to obtain even better results. And finally, to conclude, what we have learned along the way, thanks to this project, is that field trials, as Jose pointed out at the beginning, are really complex and can bring really some difficulties to really validate what we have been working on for so much time. But the general goal of decreasing risk, cost, and time is there with this kind of platforms. We think that this could bring additional benefits to the inspection of this kind of infrastructure. And also, I would like to point out that even though this safety payload that I introduced may not be the actual goal of the inspection, it will be an enabling factor to actually be able to deploy this tool, these UAV-based tools, for the future integration in the general airspace. That will be everything from my side. Thank you very much.